Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. Let's try it. We'll do it. And at the end, we'll do Throwback Thursday, where we look at a test from 30 years ago. Okay, circle theorem. Okay, a circle with center S has a radius of 10 inches, is, as shown, rounded to the nearest tenth of an inch. What is the length of arc X, Y, Z? Ooh, the big arc. Ooh, be careful. Be careful, the big arc. So, you can just, if you know the formula, the arc length, S, is equal to r theta. But this has to be in what's called radians. Has to be in radians. So r is 10. And what is theta? Theta is in radians. And the entire circle is 2 pi radians. But you have 340 out of 360th of the circle, right? The whole circle is 360 degrees. So you have 20 less. So this is 340 over 360th of the circle. So it's a proportion. You proportion out the 2 pi accordingly. If you have half a circle, then it's 2 pi times a half. If you have a third of a circle, it's 2 pi times a third. And the whole circle is 360. They only have 3/40ths of it, so it's 34 36ths of a circle, right? You can always say that too, right? It's 10, 2 pi, and then 34 over 36. Because you could simplify. So that's it, right?
Yeah.
Anything? Now, how would you do it, Seth, if you don't remember the formula? Oh, no, you can. You can do it without the formula, right?
Well, the way you do it without the formula
You
is
can do it without the formula.
is that the entire circumference,
Right. Right. That entire circumference is 2 pi times 10, 2 pi r. Oh, you have to know that. You have to know that. You have to know that the circumference, basically, what do you have to know to do this problem? The circumference of a circle. I'm misspelling circumference, okay? The circumference of a circle is 2 pi times its radius. Yeah, right, yeah. Right, yeah, circumference, right, yeah. You have to know that. So if the entire circle is 2 pi times the circumference 2 pi times 10, then it's a ratio problem, right? You proportion it out accordingly, yeah. That's a good way to do it, actually. That's a really good way to do it. That way you don't have to remember a formula. That way you don't have to remember this. Right. This way you don't even have to know anything about radians. There's this weird thing called radians. You just do it this way. The entire circumference is 2 pi r, and then you have 3/40th, 34, 36th of the circle. That's a good way to do it. We stay away from formulas. Now, I believe on the SAT they give you the formula for the circumference of a circle. Do they or do they not? Let us see. Here we have the Zeitboard, and I believe here, somewhere here, oh, no. Here is what they give you on the SAT. Do they give you the circumference of a circle? Yes, they do. They do give it to you on a reference sheet. See on the upper right, circumference of a circle, 2 pi r. So, yeah, great. So then, just go back to here. That's good, right? So now we have to do the end. Now we have to answer it according to how they want us to answer it. Round it to the nearest tenth of an inch. So that's where calculators come in. So what is it? It's 10 times 2 times 3.14 times 34 divided by 36. So it turns out to be 59.31. So that turns out to be 59.3. I don't think one would have time on the SAT to double check, but why don't we double check? I'm going to put it in different order in the calculator. 34 divided by 36 times 20 times 3.14. We get the same answer. So, should we give it a shot? 59.3?
Yeah.
Okay.
Yeah.
59.3. And we don't have to type units. Oh, yeah, let's check that. They didn't trick us with the units, did they? They didn't switch units on us, did they? No. That could be really nasty if they gave it to you in inches, but they wanted it in feet. Oh, that would be horrible.
Do they have those kinds of questions in the modern SAT?
I don't know, but something
Unit
always
conversion.
always be aware of. Plus, in terms of tests, regular school, you have to be careful of that. Okay, so they used the formula. They used the formula S is R theta, but
Yeah.
you didn't really have to do that. But as we showed the different ways to do the problem, and then they said, look, they did do this whole thing about radians.
Yeah.
But
they
yes,
did
they
the
did
radian
exactly
thing.
what I said. There were 2 pi radians and 1 revolution of a circle. So you had to know something about radians in this case. But it turns out that we looked at it from the circumference point of view. And from the circumference point of view, you don't have to know anything about radians. But because the Khan Academy is sanctioned by the SAT, you probably should know something about radians going into the SAT. Because the Khan Academy isn't fooling around. Because they partner with the SAT. So if it's on these review sheets from Khan Academy, you should know it for the SAT. Okay, so then I hate that. There's something I don't like this. They do intermediate calculations, right? They sort of waste their time with intermediate calculations here, right? You don't have to do that. Just leave everything as one big calculation.
Yeah.
Don't waste your time doing this. Plus, you have a calculator.
That's silly. If the point is in the allowing calculators is that the calculator is used as a tool, people, should be encouraged to use that tool most as efficiently as possible.
Right. So the answer should be a calculator answer. The answer should say, since you have a calculator, the answer like here should say, well, since you have a calculator, this is how you do it.
Yeah.
As opposed to doing it this way. Yeah. Okay.
And then separately have exercises for approximate calculations without a calculator.
Right. Yeah. But that we don't have. Nope. You have to prioritize. And right now the priority is getting the question right with the calculator because this is the digital SAT. And on the digital, this problem would, if they asked anything to the nearest 10th, it has to be a calculated question.
Yeah. The old-fashioned problems were artificially constructed. Old problems were artificially constructed so that the arithmetic is very easy without a calculator.
Right, of course.
Remember that?
Yeah, of course. Well, the SHSAT, the school that people use to get into Bronx Science, Stuyvesant, the specialized high schools in New York, is no calculator for anyone. Like, no calculator for anyone. And it's constructed the same way. Yeah, all the questions. There are patterns in the arithmetic, so everything.
Yes.
Okay, so today's Throwback Thursday. So let's go back to the book that was published in the late 80s. And now back this day, when these are apparently real SAT tests that they published. See, real SAT, and they tell you how many people, what percentage of people get each question right. Get each question correct. So we're going to challenge Seth today and maybe myself if I dare to go near this question. Only 19% of the people got this question right. Okay, so let's see. We'll feed it to the Seth and we'll see how he does with it. Okay, so Throwback Thursday, we go back to tests maybe from before 2016, when they were testing more of intelligence as opposed to what you learned in school. In 2016, they changed the test to basically test what you learned in school. The questions had a whole different feel. So this is a really old question from the 80s. Basically, in these types of questions, you have to decide, is column A bigger? Is column A bigger than column B, or vice versa? And if they're equal, you can, if they're equal, then that's one answer, and if they can't be determined, it's another answer. So, answer A, B, C, D if column A is bigger, etc. Okay, here we go. A, B, C are positive. Only 19% of the people got this right. The average. Oh, Seth says it's obvious. I can tell by his smirk. He said, "Oh, come on, it's so obvious how to do this, right?" Is that what your smirk says? Okay. Well,
So
back in
I'll
the
leave it
80s.
to you.
What? You're gonna leave this to
I
me?
will be silent and leave it to you.
Oh no! Oh, don't do that! Don't do that! I'm getting nervous if only 20% of the people got it right. Okay. The arithmetic average of the mean of A, B, C. We always have to consider negative numbers. The average.
No, not in this problem. They say the numbers are positive.
Oh, God! Not today is not my day. That makes it harder for me.
Strike one.
Strike one. Okay. I can't believe you're giving this to me. Okay, the average arithmetic mean of A, B, C. Okay? The average arithmetic mean of A squared, B squared, and C squared. So, this is just A. Wait, I have to annotate. This is A plus B plus C divided by 3. And this is A squared plus B squared plus C squared divided by 3. They're both positive. Aha, so they're all greater than 0. One would think that column B is always going to be bigger. But wait, there's a trick. Fractions. Fractions make things lower. Excuse me. If you have a half here and you square it, you get a quarter. Ouch. So we always consider the weird stuff. We consider the negative numbers in problems like these. We also consider the fractions. Now, the negative numbers, we don't consider the negative numbers because it's positive. But we consider fractions. So you can have a mixture, right? You can have a mixture of regular numbers and fractions. So you could have like a 1.
Whole numbers.
What?
As opposed to regular numbers. Whole numbers.
Right. Fractions and whole numbers. Positive whole numbers. Well, whole numbers are positive, aren't they? Yeah.
Depends on who you ask.
It depends on okay, right. So you could have a quarter here. Oh, you could have a 100th here. Make it a serious fraction.
Why don't you just aim for the most direct distinguishing cases?
Yeah, fractions and non-fractions. Okay, if they're not fractions, then B is definitely bigger. If they are fractions, I guess it depends on the fractions, but no. If there are fractions, it's lower, and B is lower because everything is lower, right?
The simplest distinguishing situation is when all of A, B, and C are whole numbers.
I know. I just said that.
All of them, yes.
I just said that. You consider all of them non-fractions, like I call them regular numbers, just numbers. Give me a break.
Big numbers.
Yeah.
So if all of them are greater than 1.
Fine.
Of course, if A, B, and C are 1, then the quantities are equal.
Right. Yeah, okay. So the answer is
A, B, and C are so big that when you square them, you get even bigger.
Right.
Then the squares are bigger.
Okay.
And therefore, the average of the squares are bigger than the average of the numbers themselves. If the numbers are really, really tiny positive numbers, when you square each one, it gets even tinier. So the average of the squares is tinier than the average of the sum.
Seth, but you were supposed to let me do the problem.
I just couldn't resist.
I could tell. That's fine. Okay, so it looks like the answer is D. So how did I approached it? I first looked at figure out what it looks like the answer is, what the intuition says, and then you have to question your intuition. Say, wait a second. There's a problem with fractions. And then you lead yourself to the answer. It always helps to have your brother around helping you. Okay, so the answer would be D. So, because only 20% of the people got it right, let us check the back of the book for this question. So while I'm looking at it, do you have anything else to say about it, Seth?
No.
Okay, so that's 27. 27. The answer is D. Yes. Yes,
Yeah.
yes, yes. Wow. So a lot of people forgot to consider the case of the fraction. Wow. Uh, and I looked at negative numbers, and that would have been. If I saw negative numbers, I also would have said D. Uh, so I would have been safe, even if I did the problem wrong. Let's say I did consider negative numbers, and I didn't notice they were positive. I still would have gotten the same answer, wouldn't I?
Yeah, you can't tell. Yeah.
Right. Good. Well, that's an interesting situation. You do the problem wrong. You do the problem not exactly the way you're supposed to, and you still get the right answer. That lucked out. We lucked out on that. Okay, so who are we? Joel, I have a PhD in mechanical engineering from Columbia University. Seth has a PhD in mathematics. Seth's my brother, a PhD in mathematics from MIT. He's a professor emeritus at SUNY Albany in computer science. Now retired. We are here to hopefully show you how to approach doing actual SAT sample problems or SAT questions. We offer two different approaches on the last problem. That's what we like to do. We also like to point out what the difference is between doing the problem as if it was on a test at school where you don't have as much time versus the SAT where there's a serious time constraint. And we also suggest studying for the Math SAT, go to Khan Academy. They're in partnership with the SAT people, and they offer two courses, digital and non-digital, 700 questions of each type. You can study those first and then go and do as many practice SAT tests as you can from the College Board. I think that's it. So please give us comments on our videos. We appreciate them. And if you have any SAT math questions, email them to us at satmathquestions@gmail.com. So that question wasn't as hard as it was reputed to be, was it? You never know. You never know. But you got to consider all the cases.
It's the most helpful direct principle about averages is that if you have a collection of numbers, you have two collections of numbers, right? And each number in the first collection they're positive, so you don't have cancellation when you calculate average. No, it doesn't matter. It does not matter if you have two collections of numbers, right? If each number in one collection is smaller than each number in the other collection, the average of the smaller numbers is smaller than the average of the bigger numbers.
Right. Yeah.
And again, so thinking in terms of, you have a collection of tall dogs. How do you do a tall dog? And short dogs. And all the heights of the tall dogs are bigger than the heights of the short dogs, than the average. The average height is bigger.
Right. Yeah, that's almost common sense.
Yeah, that's common sense. It's common sense about averages.
Right. Yeah.
Yeah.
Okay, so I guess that's it for today.
When you mix up, bigger in one collection, you have smaller and bigger numbers together, and the other collection, smaller numbers and bigger numbers, then how the averages compare is not determined. You have to actually find the average.
Right, you actually have to do it. Yeah. Okay, so I guess that's it for today, right?
Yeah,
that's it for today. Okay, everyone, have a great day.